Okay, good. We'll continue. Okay, once again, welcome to this topic. Is it visible again? Okay. Now we have to discuss an important principle in equilibrium, that is Cliche principle. Intermediate నుంచి చదువుకుంటూ వస్తున్నారమ్మా మీరు. సో మళ్ళీ ఒకసారి once again we have to recollect and recall this principle, and in what way we have to what way the questions will come, what way we have to apply this Cliche principle to the reactions. So let us recollect and recall all that principle. Same, you might have studied the Cliche principle. If an equilibrium is subjected to a stress, the equilibrium shifts in such a way as to reduce that stress. Stress means stress or change. అంటే మనకు ఈక్విలిబ్రియంలో ఏమైనా చేంజ్ చేస్తే, ఏమైనా అంటే పారామీటర్స్ లైక్ టెంపరేచర్, ప్రెషర్, కాన్సంట్రేషన్, వీటిని చేంజ్ చేస్తే ఆ చేంజ్ను నల్లిఫై చేసే విధంగా ఈక్విలిబ్రియం డిస్టర్బ్ అవుతుంది, ఆర్ క్యాన్సల్ చేసే విధంగా ఈక్విలిబ్రియం మారుతుంది. ఓకేనా? If an equilibrium is subjected to a stress, the equilibrium shifts in such a way as to reduce that stress. So let us illustrate this statement, and we'll see some examples. And effect of change of concentration. అంటే మనం కాన్సంట్రేషన్ మారిస్తే ఏమవుతుంది? You know concentration, which is expressed in moles per liter. అంటే ఒక లీటర్లో ఎన్ని మోల్స్ ఉన్నాయి అనేటువంటిది మనకు కాన్సంట్రేషన్ తెలియజేస్తుంది, లేదా క్వాంటిటీ. నార్మల్లీ వీల్ ఎక్స్ప్రెస్ ద కాన్సంట్రేషన్ ఆఫ్ సొల్యూషన్, అండ్ ఫర్ గ్యాసెస్ వీల్ ఎక్స్ప్రెస్ పార్షియల్ ప్రెషర్స్. ఇంక్రీజింగ్ ద కాన్సంట్రేషన్ ఆఫ్ రియాక్టెంట్స్ results in shifting the equilibrium in favor of the products. సపోజ్ మనం రియాక్టెంట్ కాన్సంట్రేషన్ ఇంక్రీజ్ చేస్తే, ఆ ఇంక్రీజ్ అయినటువంటి రియాక్టెంట్స్ తగ్గే వైపు ఈక్విలిబ్రియం మారుతుంది. ఎటువైపు తగ్గుతుంది? రియాక్టెంట్స్ ప్రొడక్ట్స్ గా మారితే వాటి యొక్క కాన్సంట్రేషన్ తగ్గుతుంది. రియాక్టెంట్స్ ప్రొడక్ట్స్ గా మారుతాయి, దట్ ఈస్ ఫార్వర్డ్ స్టెప్ జరుగుతుంది. ఈక్విలిబ్రియం అనేది ఫార్వర్డ్ స్టెప్ వైపు మారుతుంది. And increasing the concentration of products. Suppose if you increase the concentration of products, so for this reaction, so that the equilibrium disturbs in such a way that the products reconverts into reactants, that is backward reaction. And next, let us say the effect of temperature. Temperature మారిస్తే ఈక్విలిబ్రియం ఏమవుతుంది? Depending on release of energy, that is heat, we can say the reactions are two types, that are endothermic and another one is exothermic. Suppose N2O4, which gives N2NO2, delta H is plus 59 kilojoules. That is change in enthalpy or change in heat energy. If it is plus 59 kilojoules, so delta H positive indicates endothermic. Delta H negative is exothermic. Okay, now delta H positive unte endothermic and delta H negative unte exothermic. So let us see this one. On increasing the temperature, equilibrium shifts towards endothermic, because in endothermic absorption of heat takes place. That means that the reaction temperature decreases, so that the reaction shifts towards equilibrium shifts towards endothermic. And if the temperature is decreased, the equilibrium shifts towards exothermic, that is release of heat. Suppose for this reaction, take this example, N2O4 2NO2, which is endothermic, forward state. మనం ఇక్కడ టెంపరేచర్ ఇంక్రీజ్ చేశాను, ఎటువైపు ఈక్విలిబ్రియం చేంజ్ అవుతుంది, ఎండోథర్మిక్ సైడ్, దట్ ఈస్ ఫార్వర్డ్ స్టెప్. అంటే మనకు NO2 ఎక్కువ ఏర్పడాలంటే టెంపరేచర్ ఎలా ఉండాలి, మోర్ టెంపరేచర్. సపోజ్ ఫర్ సేమ్ రియాక్షన్, ఇఫ్ యూ డిక్రీజ్ టెంపరేచర్ డిక్రీజ్ చేస్తే ఏమవుతుంది, ఈక్విలిబ్రియం అనేది ఎక్సోథర్మిక్ వైపు మారుతుంది. సో బ్యాక్వర్డ్ స్టెప్ ఈస్ ఎక్సోథర్మిక్. So when the low temperature, the backward step takes place. That is again the N2O4 forms from NO2. And let us see for the this reaction, this example. This example, very familiar example, the formation of ammonia from N2 and H2, which is an exothermic reaction. So on increasing temperature, the equilibrium shifts towards endothermic, that is forward direction. And for this reaction, on increasing temperature, the equilibrium shifts towards backward reaction. Enduku backward reaction ikkada? Backward reaction is endothermic. Forward reaction is exothermic. అంటే ఇక్కడ మనకు అమోనియా ఏర్పడాలంటే లో టెంపరేచర్ కావాలా, హై టెంపరేచర్ కావాలా?
Low temperature, sir.
Yeah, good. According to Chatter's principle, low temperatures are required for formation of ammonia. In previous example, to get more yield of NO2, what is the condition of temperature?
High temperature, sir.
Good. High temperature. So that is effect of temperature, effect of change of temperature according to Chatter's principle. And change of pressure. మామూలుగా ప్రెషర్ అంటే మనం ఏం చెప్తాము, in terms of moles, number of moles. So on increasing the pressure, the equilibrium shifts towards decreasing side of number of moles. While decreasing the pressure, equilibrium shifts towards increasing side of number of moles. Look at this again. In a previous example, N2O4 gives 2NO2. 1 mole gives 2 moles. అంటే 1 మోల్ 2 మోల్లుగా మారింది.
Decreasing pressure, sir.
ఆ?
Decreasing in pressure, sir.
By decreasing the pressure, equilibrium shifts towards increasing number of moles.
Number of moles, yes.
ఏర్పడాలంటే what is the condition? Low pressure requires. According to Le-Chatelier's principle. And for this reaction, what happens? On increasing the pressure, the equilibrium shifts towards reverse direction. అంటే 2 moles products, 4 moles reactants. సో నెంబర్ ఆఫ్ ప్రెషర్ ఇంక్రీజ్ చేస్తే మోల్స్ పెరిగే వైపు ఈక్విలిబ్రియం మారుతుంది కదా. కాబట్టి అమ్మోనియా ఎక్కువ ఏర్పడాలంటే, ఎక్కువ ఈల్డ్ రావాలంటే, వాట్ ఈస్ ద కండిషన్? లో ప్రెషరా హై ప్రెషర్?
High pressure.
అమ్మోనియా
Low pressure.
Low pressure, sir.
Increasing
High pressure, sir.
హై ప్రెషర్. చూడండి వన్స్ అగైన్. ఆన్ ఇంక్రీజింగ్ ద ప్రెషర్, ద ఈక్విలిబ్రియం షిఫ్ట్స్ టువర్డ్స్
Decreasing number of moles.
ఇంక్రీజింగ్ ద నెంబర్ ఆఫ్ మోల్స్. So on increasing the pressure, the equilibrium shifts towards a forward direction for this ammonia. ప్రెషర్ ఇంక్రీజ్ చేస్తే మోల్స్ తగ్గే వైపు, ప్రెషర్ డిక్రీజ్ చేస్తే మోల్స్ పెరిగే వైపు ఈక్విలిబ్రియం మారుతుంది. దట్ ఈస్ Le-Chatelier's principle. Okay, effect of change of concentration, effect of change of temperature, effect of change of pressure. And let us move to the another topic, that is ionic equilibrium. And the earlier one, they are all chemical equilibrium. So let us discuss ionic equilibrium. Ionic equilibria is a plural. Ionic equilibrium. Now it involves dissociation of weak acids, weak bases in aqueous solutions. And we have to discuss the dissociation of sparingly soluble salts in aqueous solution. And then dissociation of water. Then hydrolytic dissociation of salts, that is salt hydrolysis. So we have to cover these topics in ionic equilibria. Dissociation of weak acids and weak bases in aqueous solutions. Dissociation of sparingly soluble salts in aqueous solution. And the dissociation of water. And the last one is salt hydrolysis. You know very well the acid-base theories. The various acid-base theories you have to know, that are Arrhenius theory, Bronsted-Lowry theory, and then Lewis theory. And we can classify, or we can say the strength of acids and bases. Some are strong acids, some are weak acids, and some are strong bases, some are weak bases. Means acids strong and weak, bases also strong and weak. But the equilibrium exists for weak acids and bases, because this weak acid partially dissociates. If you take HCl, it completely ionizes H plus and Cl minus, since it is strong acid. Whereas acetic acid, weak organic acid, in aqueous solution, it gives acetate and H3O plus, isn't it? So that's why we have to discuss about weak acid dissociation in this topic. And again, for any reversible reaction, there exists an equilibrium, isn't it? So acetic acid plus water, acetate, and hydronium ion. Or in general, HA, general weak acid, plus H2O, H3O plus A minus. That is hydronium ion and A minus ion. So Kc, that is equilibrium constant in terms of concentration. Hydronium ion concentration, that is anion concentration divided by acid and water. And we'll modify this equation so that we will get some relations. So Kc, the concentration of water is constant because we'll take in large excess. So Kc into K, sorry, Kc equal to H3O plus into A minus by Ha into K. And normally H3O plus, what do we call hydronium ion, which we can normally generally represent with H plus. Both are same. H plus is surrounded by water molecules. So we'll write H3O plus. H3O plus, instead of H3O plus, we can also mention H plus into A minus by Ha into K. And bring this K term to this side, Kc into K. Kc into K, that is Ka equal to H plus by A minus divided by Ha, where Ka is the acid dissociation constant. What is that equation? Any one of you respond? Acid dissociation constant for a general reaction Ha plus H2O, which is in equilibrium with H plus and A minus. చెప్పండి అమ్మా, ఎవరన్నా ఒకరు చెప్పండి. వాట్ ఇస్ ద acid dissociation constant equation?
Ka is equal to concentration of H plus and concentration of A minus divided by concentration of Ha.
Good. Look at this specific example so that we can have some relations between acid dissociation constant C and alpha. Again, further, acetic acid H plus acetate. Original concentration, let it be C, and the concentration at initially 0, 0, and at equilibrium concentration. So C alpha, where alpha is the degree of dissociation. Alpha is the degree of dissociation. So C into 1 minus alpha, C alpha and C alpha. So this is acetic acid, H plus and acetate. So Ka equal to H plus concentration into acetate concentration divided by acetic acid. So by substituting these values, C alpha and C alpha by C into 1 minus alpha, or Ka equal to C alpha square by 1 minus alpha. But for weak acids, the degree of dissociation is very small, or less than 1. Alpha is very, very less than 1. So 1 minus alpha nearly equals to 1. So we'll get another relation, Ka equal to C alpha square. Acid dissociation constant, concentration, degree of dissociation. Or we can write alpha equal to square root of Ka by C. So for two weak acids of dissociation constants Ka1 and Ka2 at the same concentration C. So which means uh, we can relate the two different acids. Relatively, we can say the degree, depending on different degree of dissociation, the depending on the acid dissociation constant, we can say the degree of dissociation or relative strength of acids. ఈ రిలేషన్స్ గుర్తుపెట్టుకున్నాము. Ka equal to C alpha square or alpha equal to square root of Ka by C, where alpha is the degree of dissociation. And alpha measures the strength of acid, as I told. The strength of one acid divided by strength of another acid equals to square root of Ka1 by Ka2. For example, in formic acid and acetic acid, both are carboxylic acid, and which is strong, which is weak, we can explain, or we can tell that which is strong, which is weak, if you know the acid dissociation constant. So acid dissociation constant of formic acid is 1.77 into 10 power minus 4. And acid dissociation constant of acetic acid is 1.75 into 10 power minus 5. So by simplifying, we'll get 3.18. So which indicates formic acid is 3 times stronger than acetic acid. So formic acid is more strong than acetic acid. How many times? 3.1 times, 18 times. Okay, now is it clear? Shall I explain once? Any one of you respond? Alpha 1 by alpha 2. What is alpha? Degree of dissociation, which we can relate with the acid dissociation constant. And alpha measures the strength of acid. అంటే అది ఎంత డిసోసియేట్ అవుతుందంటే దాన్ని బట్టి ఆ నెంబర్ ఆఫ్ H+ అయాన్స్ వస్తాయి. దాన్ని బట్టి దాని యొక్క strength చెప్పొచ్చు, whether it is weak or strong. And another relation, alpha can be obtained from conductive measurements. కండక్టోమెట్రీలో మనకు లేదా ఎలక్ట్రోకెమిస్ట్రీలో వస్తుంది. ఆల్ఫా ఈక్వల్ టు equivalent conductance at particular concentration divided by equivalent conductance at infinite dilution or zero concentration. So we have molar conductance and equivalent conductance. మనకు అక్కడ ఎలక్ట్రోకెమిస్ట్రీలో వస్తుంది, ఇది గుర్తుపెట్టుకోవాలి. ఆల్ఫా, which is degree of dissociation, equal to equivalent conductance at particular concentration and equivalent conductance at infinite dilution. అంటే మనం ప్రీవియస్ దాంట్లో H ప్లస్ ఈక్వల్ టు C ఆల్ఫా చూసాం కదా. సో బై దట్ వీ కెన్ క్యాలిక్యులేట్ కాన్సంట్రేషన్ ఆఫ్ H ప్లస్, దట్ ఈస్ H plus equal to C alpha. And what is alpha? If we substitute alpha with the square root of Ka by C, then we get a H plus equal to Ka into C. So write or remember all these relations, equations. Now similar to weak acid, we can also write for weak base. So let us go quickly. BOH equal to BOH, which is a reversible reaction, B plus OH minus, and since it is reversible, will attain the equilibrium position. So for that, Kb equal to B plus concentration into OH minus concentration by BOH concentration. Now similar to that, Ka equal to C alpha square, here also we write Kb equal to C alpha square, alpha equal to square root of Kb by C. Then OH minus concentration equal to C alpha. C into Kb square root of Kb by C. OH minus concentration equal to square root of Kb into C. Okay, are they clear? What is alpha? Any one of you respond?
Degree of dissociation.
For acids, the relation between Ka and alpha is, for weak acids,
Under root of Ka by C.
alpha equal to square root of Ka by C. Then dissociation of water. You know water, H2O liquid, when it dissociates into H plus and OH minus ions in aqueous solution. So for this also, we apply the law of mass action. Since it is also attains equilibrium. So K equal to H plus concentration into OH minus concentration by H2O concentration. So by modifying that, we'll get Kw equal to H plus concentration into OH minus concentration. Here Kw is called ionic product of water. So what is Kw? Ionic product of water. And its value is 1.0 into 10 power minus 14 mole square per decimeter power minus 6 at 25 degrees Celsius. Now since for water, H plus is concentration equal to OH minus concentration. So that you can write square root of Kw, and Kw value is 1 into 10 power minus 14. So we'll get 1 into 10 power minus 7. So H plus concentration equal to OH minus concentration equal to 10 power minus 7 moles per decimeter square. Then you know pH scale very well, you are familiar with this one. So let us see the relations quickly. So what is pH? Minus log H plus concentration or minus log H3O plus concentration. And the scale would be from 0 to 14. Since the 1 molar concentration HCl pH is 0 and 1 molar concentration of NaOH pH is 14. So the scale is between 0 to 14 pH scale. And we can apply the similar relation to hydroxyl ion concentration. So POH equal to minus log OH. pKw equal to minus log Kw. And pH plus POH equal to pKw. Then for Ka, acid dissociation constant, pKa equal to minus log Ka. And pKb equal to minus log Kb. And let us see the buffer solution. So this also you know something. Buffer solution. So any one of you, can you tell me what is the buffer solution? How we can say buffer solution?
అది యాసిడ్ లేదా బేస్ యాడ్ చేసినప్పుడు దాని pH వాల్యూలో ఏం చేంజ్ ఉండదు సార్, దాన్ని బఫర్ సొల్యూషన్ అంటారు.
A solution whose pH does not change on addition of a little amount of acid or base is called buffer solution. And buffer solutions can be classified as in two ways, two categories. The mixture of weak acid and yes.
Sir, acid and base and add చేసిన pH and value change అవుతుందా సార్? చేంజ్ కావా?
చేంజ్ కాదు, కాకుంటేనే దాని బఫర్ సొల్యూషన్.
థ్యాంక్ యూ సార్.
Suppose sodium chloride solution ఉందనుకో, ఫస్ట్ sodium chloride. సో దీనికి 1 ml HCl వేసామనుకో. Sodium chloride is neutral, but on addition of HCl, its pH reduces to 7, less than 7. Or suppose if you add a base alkali, 1 ml of NaOH, so due to more number of OH minus ions, its pH will be more than 7. So then that solution is not a buffer solution. We cannot call it as a buffer solution. But for solutions whose pH will not change, they are called buffer solutions. Let us see this one. Types of buffer solutions. Equimolar aqueous solutions of acetic acid and sodium acetate. You know, acetic acid, weak acid, and the salt formed by this acetic acid is sodium acetate. So acetic acid is very slightly dissociated, while sodium acetate is completely dissociated. So that solution consists acetate, Na plus, and acetic acid molecules that are undissociated acetic acid molecules. Suppose if we add strong acid, the H plus ions added will taken up by acetate ion. ఎప్పుడైతే యాసిడ్ యాడ్ చేస్తున్నామో యాసిడ్లో ఉన్నటువంటి హెచ్ ప్లస్ ఎసిటేట్తో రియాక్ట్ అయి అన్డిసోసియేటెడ్ ఎసిటిక్ యాసిడ్గా మారుతుంది. కాబట్టి ఈ నెంబర్ ఆఫ్ హెచ్ ప్లస్ అయాన్స్ కాన్సంట్రేషన్ పెరగదు. దెన్ pH remains constant. And when we add strong base, which consisting OH minus ion, and they are neutralized by acetic acid. So OH minus plus acetic acid gives acetate plus water. అంటే ఈ OH మైనస్ అనేటువంటివి న్యూట్రల్ వాటర్ మాలిక్యూల్ గా మారుతుంది. కాబట్టి OH మైనస్ అయాన్ కాన్సంట్రేషన్ ఇంక్రీజ్ కాదు. నెంబర్ ఆఫ్ OH minus concentrations will not increase. So pH remains constant. For calculating pH, we use an equation which is called Henderson's equation. pH equal to pKa plus log salt concentration by acid concentration. This equation for calculating pH. Here Ka is the acid dissociation constant of weak acid. So this also an important relation, remember. Henderson's equation. And buffer mixture of weak base and its salt. Ammonium hydroxide and ammonium chloride. When strong acid is added, H plus converts into water by NH4OH. So that the H plus concentration will not increase. And when strong base is added, OH minus ions reacts with NH4 plus, will get a undissociated NH4OH. And similarly, Henderson's equation, POH equal to PKB plus log salt concentration by base concentration. Since it is a basic buffer solution, we write a POH. And for calculating pH, what do we do? pH equal to 14 minus POH. The next one is hydrolysis of salts or salt hydrolysis, simply. Salt hydrolysis. So the interaction of anions and cations of the salt with H plus and OH minus ions by water, which yields acidic or alkalinic solutions, is known as salt hydrolysis. See once again, the interaction of anions and cations of the salt with H plus and OH minus ions by water, that is in aqueous solution, which yields acidic or alkalinic solutions, is known as salt hydrolysis. Then salts, the different salts we can classify formed by strong acid and strong base. Salts of strong acid and strong base. Okay, strong acid, strong base తో ఏర్పడిన salts. Example, if you take HCl and NaOH, on neutralization, what do we get? NaCl. So this salt is formed by strong base and a strong acid. So like that. So the remaining salts also formed by strong, the reaction between strong acid and a strong base. And these do not undergo hydrolysis, since the cation and anion belongs to strong acid and strong base. And the next one, salts of weak acid and strong base. Since the salts of weak acid and strong base, example, sodium acetate. Sodium acetate dissociates into acetate and sodium plus ion the acetate which is a part of weak acid, and it's a strong conjugate base. Acetate అనేది దేని నుంచి వచ్చింది మనకు? ఎసిటిక్ యాసిడ్. ఎసిటిక్ యాసిడ్ వీక్ యాసిడ్. వీక్ యాసిడ్ యొక్క కాంజుగేట్ బేస్ ఎలా ఉంటుంది? స్ట్రాంగ్ ఉంటుంది. So that the acetate reacts with H plus will get a acetic acid. As the number of OH minus ions increases, the solution is alkaline in nature. కాబట్టి sodium acetate aqueous solution alkaline in nature or basic in nature. So acetate plus water gives acetic acid plus OH minus ion. అంటే ఈ OH మైనస్ అయాన్స్ కాన్సంట్రేషన్ ఇంక్రీజ్ కావడం వల్ల దానికి ఆల్కలైన్ నేచర్ వస్తుంది ఆ సొల్యూషన్. అండ్ ఫర్ దిస్ హైడ్రాలసిస్ కాన్స్టెంట్ KH ఈక్వల్ టు ఎసిటిక్ యాసిడ్ కాన్సంట్రేషన్ ఇంటూ OH మైనస్ కాన్సంట్రేషన్ బై ఎసిటేట్ కాన్సంట్రేషన్. అంటే ఇక్కడ వాటర్ కాన్సంట్రేషన్ విల్ టేక్ యూనిట్ 1 which is equal to 1. So for acetic acid, we write Ka, acid dissociation constant.
Yes, sir.
What?
OH
minus. Kw equal to H plus into OH minus. And from these three equations, we'll write the KH equal to Kw by Ka. So finally the relation is KH equal to Kw by Ka. What is KH? Hydrolysis constant. Kw is the ionic product of water. Ka is the acid dissociation constant. And let us move quickly because the similar explanation and similar equations will get. Salts of weak bases and strong acids. Example NH4Cl. NH4Cl దేని నుంచి వస్తుందమ్మా? NH4OH plus HCl. అంటే స్ట్రాంగ్ యాసిడ్ వీక్ బేస్. సో వీక్ బేస్ పార్ట్ ఏంటి అక్కడ? NH4. సో ఇట్ అండర్గోస్ హైడ్రాలిసిస్. NH4 plus water gives NH4OH plus H plus. Since number of H plus ions increases, it is a acidic in nature. The solution is acidic in nature. So the hydrolysis constant equal to, again, KH equal to NH4OH into H plus by NH4 plus. So we'll get a KH equal to KW by KB. Previous one is KH equal to KW by Ka. Ionic product of water, acid dissociation constant. And the last one is salts of weak acid and weak base, ammonium acetate. In this, both acetate ion and ammonium ion undergoes hydrolysis, will get acetic acid and H4OH. Now, depending on the formation of acetic acid, suppose if acetic acid formation is more, which means OH minus concentration will be more. Relatively, it will be alkaline nature. Suppose ammonium hydroxide forms NH4OH with water, H plus ions increases, so that it will be it will have acidic in nature. And depending on acetate and ammonium. ఇక్కడ మైనస్ కాదు, ప్లస్ ఇది upward. NH4 plus, not NH4 minus. So for this, KH equal to acetic acid concentration into NH4OH concentration by acetate concentration and NH4 plus concentration. So we write KH equal to KW by KA into AB. Oh. So let us discuss acid-base titrations. So Ramesh sir, shall I take 15 minutes more?
Okay, carry on.
Okay.
Sir, join అన్నట్లేదు.
I completed. The topic
Okay.
completed.
Okay.
Now acid-base titration. The process of acid-base titrations is accompanied by a change in pH. So you might have studied about titrations in a theory and practicals. And let us understand some points and some aspects of titrations, acid-base titrations, and so that the questions will expect an exam based on this topic. So the process of acid-base titrations is accompanied by a change in pH. The యాసిడ్ వర్సెస్ బేస్ రియాక్షన్ చేసినప్పుడు అక్కడ pH మారుతుంది. ఆ pH మారేదాన్ని బట్టి మనము ఆ న్యూట్రలైజేషన్ ఐడెంటిఫై చేస్తాము, ఎండ్ పాయింట్ ఐడెంటిఫై చేస్తాము. So for this, a plot between pH of solution during the titration and the amount of acid or alkali added from a burette is called a titration curve. మామూలుగా గ్రాఫ్ వాల్యూమ్ ఆఫ్ ఆల్కలి ఆర్ వాల్యూమ్ ఆఫ్ బేస్ pH. సో pH ఎలా మారుతుంది అనే దాన్ని బట్టి విల్ డ్రా ఎ గ్రాఫ్. The relation between pH and volume of acid or alkali added is called titration curves. So what is titration? Titration curve, a plot between pH of solution during titration and the amount of acid or alkali added from a burette is called a titration curve. And in this titrations, we use indicators. What is the purpose of using indicators? To find end point. So on account of hydrolysis, the pH at end point depends upon the relative strength of acid and base being titrated. And since different indicators have different pH ranges, the selection of proper indicator for a given titration is very important. Let us see that. So see these examples, different indicators. I have written few examples like methyl orange, methyl red, phenol red, phenolphthalein. Every indicator has pH range. So 3.1 to 4.5 and 4.2 to 6.3 for methyl red. For phenol red, 6.4 to 8.2. Look at this phenolphthalein, 8 to 9.8. And the indicators shows different colors in acidic medium and alkaline medium. Suppose methyl orange in acidic medium, it exhibits red color. And in alkaline medium, it exhibits yellow color. And methyl red also same color, but the pH range is different. If you take phenol red, its pH range is 6.4 to 8.2. And it exhibits yellow color in acidic medium and red color in alkaline medium. And phenolphthalein in acidic medium colorless, and in alkaline medium it exhibits pink color. So let us see titration of strong acid versus strong base like HCl and NaOH. (25 ml of 0.1 m HCl to be titrated against 0.1 m NaOH. Now pH change for this titration is 3 to 10. అంటే ఆ కర్వ్లో టైట్రేషన్ కర్వ్లో 3 వరకు స్లోగా పెరుగుతుంది. 3 నుంచి నెక్స్ట్ 10 వరకు సడెన్ ఇంక్రీజ్ అవుతుంది. pH వర్సెస్ వాల్యూమ్ ఆఫ్ ఆల్కలీ యాడెడ్. అంటే pH చేంజ్ అనేది ఎలా ఉంటుంది? 3 to 10 ఫర్ దిస్ టైట్రేషన్. ఫర్ స్ట్రాంగ్ యాసిడ్, స్ట్రాంగ్ బేస్. కాబట్టి ఈ రేంజ్‌లో ఉన్నటువంటి ఇండికేటర్స్ ఏవైనా మనకు యూజ్ అవుతాయి. దట్ ఈస్ సెలక్షన్ ఆఫ్ ఇండికేటర్. So any indicator with this range, within this range, is to find the end point. Either we take methyl arranger or phenolphthalein. Now titration of weak acid versus strong base. Acetic acid versus NaOH. Now pH change takes place for this titration at 8 to 10. కాబట్టి 8 to 10 రేంజ్‌లో ఉన్నటువంటి ఇండికేటర్ ఏది ఇందులో? ఐదర్ ఫినాల్ రెడ్ ఆర్ ఫినాప్థలిన్, the suitable indicator. So we cannot use methyl orange or methyl red. And let us see the solubility product. In a saturated solution of a salt, there is a dynamic equilibrium between the excess of solute and ions. Sparingly soluble salt ante takkuvaga karigeటువంటి salt. Suppose if you add a solvent, if you add salt to a solvent, it dissociates partially. Suppose silver chloride, which is a sparingly soluble salt. So this undissociated silver chloride and silver plus chloride ions. So there exists an equilibrium. So for this, if you apply law of mass action, K equal to activity of silver plus into activity of chloride ion divided by activity of silver chloride, and bring this term to this side so that the activity of silver chloride is unity since it is solid. So we write KSP. What is KSP? Solubility product. Activity of silver plus and activity of chloride ion. So generally, we mention the activity in terms of the active mass or activity in terms of concentrations. Solubility product in terms of concentration. Solubility product in terms of activity or active mass. So concentration solubility product. So KSP equal to concentration of silver plus into chloride ion for sparingly soluble silver chloride salt. And similarly, Ag2SO4, which is also a sparingly soluble salt, we can write KSP equal to silver plus to the power of 2 into SO4 minus 2. In general, for the salt, remember this equation is important. AXBY dissociates into X into A to the power of Y plus Y into B to the power of X minus. So the relation between KSP and solubility of a sparingly soluble salt. S is the molar solubility of salt. Concentration of A plus is S, concentration of B minus is S. So moles per decimeter cube. So for this one, so KSP equal to S into S square. Solubility product, S is solubility. Let us see some of the model questions, numerical problems. So I think there are 3, 4 are there. Okay, shall I continue, Ramesh sir? నాకు మోడల్ క్వశ్చన్స్ ఉన్నాయి కొన్ని ఎక్స్ప్లెయిన్ చేయన్నా
భయ్యా ఇంకొంచెం కంటిన్యూ చేయండి, ఎట్లాగే సార్ తీసుకోవట్లేదు ఇక.
సరే సార్, ఓకే గుడ్.
మీరే ఇంకా కొంచెం కంటిన్యూ చేస్తే మీతోనే ఎండ్ చేసేద్దాం.
సరే సార్, ఓకే. ఓకే స్టూడెంట్స్, ఆర్ యూ లిజనింగ్?
భయ్యా ఉన్నారు, క్యారీ.
కొన్ని ప్రాబ్లమ్స్ చూద్దాము, కొన్ని మోడల్ ప్రాబ్లమ్స్ చూద్దాము. A monobasic acid has a dissociation constant equal to 1.8 into 10 power minus 5 at 25 degrees Celsius. Calculate the degree of dissociation at concentration of 0.2 molar at the same temperature. So what is the concentration of H plus? So read thoroughly the problem or question. After understanding the problem, you have to apply the you have to substitute the given values in a suitable equation. అక్కడ ఏం కనుక్కోవాలమ్మా? డిగ్రీ ఆఫ్ డిసోసియేషన్. మనకి డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా. ఏ వాల్యూస్ ఇచ్చాడు అక్కడ? కేఏ ఇచ్చాడు, యాసిడ్ డిసోసియేషన్ కాన్స్టెంట్, అండ్ కాన్సంట్రేషన్ ఇచ్చాడు. కాబట్టి ఆల్ఫా ఈక్వల్ టు స్క్వేర్ రూట్ ఆఫ్ కేఏ బై సి కదా. ఆ ఈక్వేషన్ అప్లై చేయాలి. కేఏ వాల్యూ ఎంత? 1.8 in 10 power minus 5. కాన్సంట్రేషన్ ఎంత? 0.2. So by simplifying, we'll get a 0.009486. అంటే ఈ క్యాలిక్యులేషన్ చేయడం అనేది, సో యూ హ్యావ్ టు యూస్ సైంటిఫిక్ క్యాలిక్యులేటర్. అది ఇస్తారనుకుంటాను, ఆ ఆప్షన్ ఉంటుంది. ఓకేనా? హెచ్ ప్లస్ కాన్సంట్రేషన్ ఈక్వల్ టు ఫార్ములా ఏంటమ్మా? సి ఆల్ఫా కదా. సి ఈజ్ ద కాన్సంట్రేషన్, ఆల్ఫా ఈజ్ ద డిగ్రీ ఆఫ్ డిసోసియేషన్. సో మల్టిప్లై చేస్తే ఏమవుతుంది మనకు? 0.2 into 0.009486. సో వాట్ డు వి గెట్? 0.001897 moles per decimeter cube. Okay, is it understood? Then another one, calculate the pH of an aqueous solution obtained by mixing 25 ml of 0.2 molar HCl with 50 ml of 0.25 molar NaOH. Kw is 10 power minus 14 mole square decimeter power minus 6 at 25 degrees Celsius. అక్కడ వాల్యూమ్ ఇచ్చాడు, కాన్సంట్రేషన్ ఇచ్చాడు, HCl and NaOH. Then Kw ఇచ్చాడు. So what we have to find? pH. So what is the method of doing? So number of millimoles of acid equal to 25 into 0.2, which is equal to 5. And number of millimoles of alkali, that is 50 into 0.25, 12.5. And the number of millimoles alkali left, అంటే మిగిలిపోయినటువంటి ఆల్కలి, బికాస్ ఆల్కలి మిల్లీమోల్స్ ఎక్కువ ఉన్నాయి అక్కడ 12.5. 12.5 minus 5, 7.5. The total volume is 50 plus 25, 75 ml. So OH concentration equal to OH concentration equal to 7.5 by 75, which is multiplied with 1000 and 1000 to get a per liter or per cubic decimeter. దీన్ని సింప్లిఫై చేస్తే ఏమవుతుంది? 7.5 by 75, 0.1 moles per cubic decimeter or 0.1 moles per liter. And Kw equal to 10 power minus 14. The H plus into OH minus equal to 10 power minus 14. OH we obtained as 0.1. So we get H plus concentration equal to 10 power minus 14 divided by 0.1. So we get 10 power minus 13. pH equal to, formula is minus log H plus concentration. So by substituting that value, we'll get a 13. See once again. Calculate the pH of an aqueous solution obtained by mixing 25 ml of 0.2 molar HCl with 50 ml of 0.25 molar NaOH. Kw is a 10 power minus 14. The number of millimoles of acid is 5. Number of millimoles of alkali is 12.5. Number of millimoles of alkali left is 7.5. Then total volume of the solution is 75 ml. So finally we'll get a pH 13. So like this, you have to practice some numerical problems. Is it clear? Is any one of you respond, students? చూసారమ్మా ఈ ప్రాబ్లమ్స్ రెండు?
ఓకే సార్.
గుడ్. ఇట్లాంటి కొన్ని ప్రాక్టీస్ చేయండి, మోడల్ క్వశ్చన్స్ ఇవి. అండ్ దెన్ లాస్ట్ వన్ ఈస్ క్యాలిక్యులేట్ ద, అంటే ప్రీవియస్ పేపర్లో కూడా క్వశ్చన్స్ చూడండి, మోడల్ క్వశ్చన్స్ తెలుస్తాయి, ఐడియా వస్తుంది. ఐఐటి జామ్
సార్ పీపీటీ షేర్ చేశారు సార్ ఈరోజు? పీపీటీ షేర్ చేస్తారు సార్ ఈరోజు?
పీపీటీ calculate the pH of 2 into 10 power minus 5 molar aqueous solution of phenol at 25 degrees Celsius. And its Ka value is 1.3 into 10 power minus 10. And Kw is 1.008 into 10 power minus 14 at that temperature. Look at that. Phenol, which is weak acid, it dissociates into phenoxide and H plus. And initial concentration is 2 into 10 power minus 5. At equilibrium, X moles of phenoxide and X moles of H plus ions form. So we can write 2 into 10 power minus 5 minus X at equilibrium. X indicates moles of phenoxide and H plus concentration. So Ka equal to X square by 2 into 10 power minus 5 minus X. Since X is very small, we can neglect the X value in denominator. X square by 2 into 10 power minus 5. So X equal to Ka into 2 into 10 power minus 5 to the power of 1 by 2. X equal to H plus concentration. So we'll get by simplifying this, substituting Ka value and simplifying, we'll get 5.1 into 10 power minus 8. But by taking this value, we'll get a pH more than 7 or less than 10 power minus 7. Since it is acid, pH less than 7 undali, not more than 7. ఈ వాల్యూ తీసుకుంటే more than 7 వస్తుంది. That's why it should be greater than 10 power minus 7, like 10 power minus 6, 10 power minus 5, etc. Not 10 power minus 8. Now to obtain the correct value for H plus, we apply concept of electroneutrality. Electroneutrality of the solution. Let us see the steps involved in this. H plus concentration equal to phenoxide concentration plus OH minus concentration. And H plus concentration into OH minus concentration equal to Kw. OH minus concentration equal to Kw by H plus. So from here, phenoxide equal to H plus minus OH minus. OH minus same రాశాం ఇక్కడ Kw by H plus. Phenol plus phenoxide equal to 2 into 10 power minus 5. మనకి ఇచ్చిన కాన్సంట్రేషన్ with respect to phenol as well as phenoxide. But since the phenol is weak acid, the concentration of phenoxide is very, very small compared to phenol. So phenol concentration equal to 2 into 10 power minus 5. So Ka equal to phenoxide by H plus divided by phenol concentration. ఇక్కడ phenoxide ఏం రాసుకున్నాం మనం ఇక్కడ H plus minus Kw by H plus into H plus divided by 2 into 10 power minus 5, which is the given value, and which is equal to Ka. Ka also is a given value, 1.3 into 10 power minus 10. Now by simplifying this equation, H plus concentration square minus Kw equal to 2 into 10 power minus 5 into 1.3 into 10 power minus 10. And Kw value is 1.008 in 10 power minus 14. And by multiplying, we'll get 2.6 into 10 power minus 15. H plus concentration square equal to 1.268 into 10 power minus 14. H plus concentration equal to 1.126 into 10 power minus 7. And now we can substitute the H plus concentration in pH so that we'll get a 6.95. Okay, now phenol, which is a weak acid, its pH should not be more than 7. So final ga manaki ento ochindamma 6.95. Suppose if we take this value 5.1 into 10 power minus 8, we'll get more than 7. Acid ku more than 7 ఉండదు కదా. కాబట్టి we apply the concept of electroneutrality. So finally we'll get a pH value 6.95.
సార్ అక్కడ ఫినాల్ ప్లస్ ఫినాల్ అది అయాంది ఎందుకు యాడ్ చేశారు సార్?
ఎందుకంటే the given concentration belongs to phenol as well as phenoxide ion. ఇది కదా. అదేనా?
ఎస్ సార్.
ఇచ్చిన కాన్సంట్రేషన్ అనేది it belongs to phenol as well as phenoxide ion. But since phenol is weak acid, కాబట్టి phenoxide అనేది చాలా తక్కువగా ఉంటుంది. So that this concentration is equals to concentration of phenol only, not phenoxide. We can theoretically say that the concentration belongs to both. But the phenoxide concentration is very less compared to phenol, so that the concentration which is equals to phenol only. Okay, now?
ఓకే సార్.
These are some model questions. You practice more questions and see the previous questions, model questions, so that practice in that way. Okay, thank you. So we'll stop here. Okay, anything you want to ask?
సార్ పీపీటీ షేర్ చేయరా సార్ గ్రూప్ లో?
పంపిస్తాను. నోట్స్ అవి పేపర్లో రాశాను. పీపీటీ అంటే స్లైడ్స్ కాదు.
ఓకే సార్, థ్యాంక్ యూ.
నోట్స్ సినాప్సిస్ లాగా నోట్స్ రాశాను ఇన్స్టెడ్ ఆఫ్ డూయింగ్ ద పీపీటీ. ఓకే, పంపిస్తాను.
థ్యాంక్ యూ సార్.
ఓకే. రమేష్ భాయ్
కంప్లీట్ అయిందా?
కంప్లీట్ అయింది.
ఓకే ఓకే భాయ్, థ్యాంక్ యూ. నేను ఎండ్ చేపిస్తాను.
రైట్, థ్యాంక్ యూ.
రైట్ రైట్
ఓకే
భాయ్, థ్యాంక్ యూ. నెక్స్ట్ మళ్ళీ ఎప్పుడు?
ఎల్లుండి తీసుకుంటాను, 27th.
భాయ్ థ్యాంక్ యూ వన్స్ అగైన్. రైట్.
సార్ చంద్రమౌళి సార్ క్లాస్ లేదా సార్?